Here we have one of the latest motors from DYS. This one is the THOR, and this one is 2500 kV. Lately, DYS has been naming their motors with some pretty interesting names: Fire, Storm, Thor, Mars, but they don't give any size of motor per se. You know, they don't tell you if it's a 2205, 2207, 2206, 2306, or 24, whatever. You know, they don't tell you. But anyways, you know, we eventually will find out what the actual size of the stator is. So this motor, as you can see, they're keeping the same theme that they started with the Fire. Same anodized purple color and one piece shaft, and the same design on the bell. So here's the first one with this theme was the Fire. So you can see it's pretty similar, but you can see the difference in diameter. In height, surprisingly, they're about the same height, not that much difference, you can see there. So the other thing they've been doing is they've got rid of a lot of material on the base, I guess because they're trying to lose a lot of whatever weight they can, because they've been increasing weight on the stator and the diameter and height of the stator. That's where most of the weight comes from in a motor. This one's pretty big motor. I guess it's aptly named Thor. I believe the kV available, I think it's going to be 2200, 2500, and 2700 kV. Now they come on these boxes. Before they used to come on plastic or plastic boxes. So now they're using these cardboard boxes, which is good. I guess this is more recyclable. And so this one's, and they just come back like that. And again, they include 2 prop nuts and 2 sets of screws, M3x5 and M3x7. I guess those must be for 3mm arms, thick arms, and for 4mm thick arms. This is the 2700 kV, which I'll be testing in a few days. I just gotta do some testing on this motor and some other motors that I have on queue, and also got the Mars 2400 kV, which is very similar to this one, but it's smaller, as you can see. So that's the Mars. So DYS is not too descriptive about the motor on its on the website. They don't say, there's not that much detail on the specs. Again, they don't tell you the stator size. They don't say anything about the magnets or laminations or shaft, what material it is. So that's kind of annoying. I mean, they should tell you more. I guess if they're using good components, they should mention it. Like these bearings, I was surprisingly these are really good bearings. They're ISO bearings, so those are some of the best. So I'll put it on the magnifying glass in just a bit. Okay, so DYS is saying the motor's about 37.45 grams. Now they give you about 200mm worth of wire, motor lead wire, which is pretty good. That's good for center mounted ESCs when they're in those 4x1 ESCs, so that's a good length. It should be good enough for any of the 5-inch frames. So with that long wires, the motor weighs in at 40.5 grams. So what I did is I measured if you cut them so that the wires are only about 50 to 55 millimeters, which is enough length if you have arm mounted ESCs, then you have this much excess wire. So approximately this is going to be the excess wire, which is about 430 or so millimeters worth of wire. So that weighs in at about 3 grams. So let's say that's about 3 grams. So 40.6 minus 3, it's about, so the motor is about 37.6 or so, depending on how long you leave the wires. So if you cut them shorter, then it's gonna be 37.5, 37.4. So right about there, 37.5, 37.6 grams. So kind of heavy, which is to be expected. As the motor gets larger, weight increases. Alright, so let's look at the close-up. There's the bottom bearing, ISO bearing, so that's pretty good. They're using high quality bearings, and there you can see the magnets and the air gap distance between the face of the magnet and face of the stator arm or tooth. So not overly tight and not that loose either, so should make for a fairly smooth running motor. So sometimes if you have the gap too tight, it may cause some yaw shakes with some FCs. So now let's get this out. The DYS doesn't really mention size of stator or magnet type of magnet, so but these are probably N52 magnets, maybe. They kind of have that silvery color to them, and as you can see, they're not really curved. They're not using curved magnets lately. The DYS is only using square magnets, so I guess that's one way to keep motors at a certain price target, I guess. But it's alright. I mean, yeah, as long as they still make good power and they're decent price, why not? As you can see, the shaft is the typical one piece. It's 4 millimeters through the motor and 5 millimeters for the shaft. So it's 5, and then it's turned down to 4 here. And the stator windings look pretty decent. It's multi-strand wire. Fairly decent job on the windings. The laminations, I think I saw somewhere that these were 0.15 thick laminations. So you can see they actually use some epoxy or glue here where the wire, where they join the motor lead wires. So that's good, you know, some attention to detail there. So they're not just loose right there. And now let's look at the size of this hammer of a stator. Just get it right there. So that's right about 24 millimeters in diameter, and in height measuring 7.5 on these. So yeah, I'm measuring 7.5 on the stator. So definitely an odd size, because they're usually 6, 7, or 8. So on this one they decided to go with 7.5. So pretty interesting. Not a bad thing, It's something in the middle, a little bit higher, bigger than 7, but not as tall as 8. So there you go. That's the teardown and overview of the DYS THOR. This one's the 2500 kV. Pretty interesting motor, so let's see what it can do on the truss stand. So let's look at the thrust test results for the DYS THOR 2500 kV. This motor measured at 24 millimeters diameter on the stator by 7.5 height, and kV was measured at about 2575. So I went ahead and tested the usual props, since these are some of the most widely used. There are two props that I also included because these were sent by DYS along with the motors. I guess they want to see some testing of these props, so I just threw them in right here. Is these two, the DYS XT5043 and the DYS XT5045, both tri-blade props. So the Gen Fan 5152, it's what I'm noticing is this prop is probably designed for fast forward flight, because on the thrust stand the numbers usually don't show good performance. The thrust is usually low for the amount of amps used. So I'm thinking this might be kind of similar to the Team Racecraft 5150, which is it's made for actual flight, and on the thrust stand it doesn't show good performance.
But I know this prop, a lot of people are liking it, so they're using it, but it just doesn't translate well what you get on the thrust stand as what you do in flight performance. The other popular prop that is it's a good measure, a good standard to have for motor tests is the 5040x3. There are many brands. HQ, one of the best. There's also DAL, DYS, Team Racecraft. A lot of manufacturers make it, and they're all pretty similar. The HQ is one of the better ones, so that's the one I use. So the motor is pretty much clearing 1500 grams on this prop and on most of the 5-inch tri-blades. It's pretty impressive to have a motor that's clearing 1500 grams pretty easily. Of course, amps are going to be higher. These two go hand in hand together. These two always go up together. Yeah, the motor's pretty strong. A lot of torque on this motor. As you can see on the 4-blade prop, almost 1600 grams of thrust at 45 amps. And again, I always say, don't get too scared about these high amp readings. These are on the thrust stand. In the air, the props will unload, and these numbers will go down quite a lot, including the thrust. Also the voltage and the amps are high because I'm using a power supply, a dedicated power supply. When you're in the air, lipos just can't sustain these high voltage and these high amps. So the limiting factor is going to be the lipo. So your amp load and your volts are going to be lower. Also, the thrust is going to be lower. So usually 25 to 35% lower amps once in the air. So with that said, these four-bladed 5-inch prop, pretty interesting to see. It's pretty close to the 3-blade prop. Not a lot of difference in thrust. 1537 versus 1598, and the amps also fairly close. So we can see that that they have pretty close performance. So the 4th blade is not really adding a lot more thrust at the top end. But I'm sure throughout the RPM range, the 4-blade might have more thrust or develop more thrust faster overall. So that's why some people like this one. So the next one is the DAL T5045B2. I included it because that's what this one's based on, the new DYS XT5045. So I included that one so I could compare it to see how the DYS does, and it does slightly better. Pretty good difference actually. 1681 versus 1617, and amps are just slightly higher, about 2 amps, 1.8 amps or so. So pretty good prop, this DYS. If you like that style of prop, that's one to consider. So then we move on to the heavier props. This DYS and DAL T5045. I guess we could include those on the heavier props. They have a lot of pitch and a lot of area for each blade. So the next one is the Cyclone 5046. It's pretty high thrust too. These are pretty much clearing 1600. The heavier props is clearing 1600, no problem. Luminaire Butter Cutter 5050x3, 1646 at 48 amps. So pretty respectable. And then we move on to the 6-inch blades. This one really tests the motor as far as load handling and torque. So if the motor can just keep making thrust with the 6-inch props, then we know it has a lot of torque, so it can pretty much drive any prop, and it'll respond to throttle inputs quite well. So almost reaching 2 kilograms of thrust on this motor. So amps are of course quite high right here for the 6-inch blade. Again, these numbers are quite exaggerated here because of the power supply and the static air, you know. So in the air, there's going to be a lot of unloading, so you won't be seeing this huge amount of amps. On 3S, still this motor is pretty viable solution if you want to do 3S on the 6-inch blade, and it's actually quite efficient. So on 3S we're clearing 1300 grams on the 6-inch prop, and on the 5-inch prop is clearing 1100 grams. So still pretty decent thrust. So there you have it. That's the thrust test results. So quite an impressive big motor. Seems like that's the trend right now of these larger diameter motors. So let's see what the next trend is. This is quite an impressive motor. Little bit on heavy side, but yeah, with this much thrust, you could probably doesn't feel that heavy once you get flying. But something to think about. And a lot of people are flying these size motors now, and they seem to like it. So this might be the next big thing. This size motor, anyways. All right. Until the next video. Thanks for watching.